Hello friends, we'll be talking about the different divisibility rules from 2 to 15 in this session. Let's now talk about the divisibility rules. We want to check the divisibility of any number. We provided a number and we want to see whether it is divisible with a specific number 2, 3, 4, 5 and so on. So these are the divisibility rules. How do we check it without actually performing a division? So that is what we mean by divisibility rules. One is the standard way that we just divide the given number with the other number with which the divisibility is to be checked, and we see whether it is divisible, whether it gives a remainder or not. But we have simpler ways of checking it. These are called divisibility rules. So we'll check the divisibility from 2 to 15. We'll see different rules for that. Now if we want to check the divisibility by 2, we know that all the even numbers are always divisible by 2. So we'll just look at the number, whether it is even or odd, and decide whether it is divisible by 2 or not. So let's just look at how do we actually reach at this conclusion that all the even numbers are divisible by 2. So we take any number ABC and represent it in a general form, which is 100A plus 10B plus C. Now for this number to be divisible by 2, we know that C has to be divisible by 2 because 100A is divisible by 2, 10B is divisible by 2. So C has to be either divisible by 2 or it should be 0. If it's 0, then it's fine. So that gives us this rule where we say that all the even numbers are divisible by 2. So divisibility by 3 is if sum of all the digits of the number is divisible by 3, then the number is also divisible by 3. Now we'll again use the same method which we used for checking the divisibility by 2 and see how it works. We take any number ABC and represent it in the general form, 100A plus 10B plus C. And now we can write this as 100A getting broken up into 99A and A. Similarly, 10B getting broken up into 9B and B. So we make this as 99A plus 9B plus ABC. Now we know that 99A and 9B are divisible by 3. So the only condition that we have to meet is that A plus B plus C, this thing, which is nothing but the sum of the digits of the number, has to be divisible by 3 to make the complete number divisible by 3. So let's now see the divisibility by 4. If the last two digits of the number, and when we say last two digits, we are talking about the tens digit and the ones digit of the number. So when we take these two digits of the number, and if they are either 0, 0 or divisible by 4, then the number is divisible by 4. So let's see how do we derive this. If we take any number ABC and write it as 100A plus 10B plus C. Now we know that 100A is anyways divisible by 4 irrespective of the value of A. So now we focus on 10B plus C. Now for this number to be divisible by 4, 10B plus C has to be either 0, 0 or divisible by 4. So the final number in any number, we are just concerned about these two digits B and C, the tens and the ones digit. So if these two digits are either 0, 0 or divisible by 4, then the complete number will be divisible by 4. Now let's look at the divisibility by 5. Any two or more digit number ending with a 0 or 5, that means the units digit of the number, if it is 0 or 5, then the number is divisible by 5. Now we not look at this, we can derive at these divisibility rules, but now we'll just focus on the rules. You can do it, try doing it and reach these rules. Now let's look at the divisibility for by 6. The number is, if the number is an even number and the sum of its digit is a multiple of 3, then the number will be divisible by 6. Now why do we say that? Because 6 is 3 multiplied by 2. So any number which is divisible by 2 as well as divisible by 3 will be divisible by 6. So for 2 we are saying the number has to be an even number, and for 3 we are saying the sum of its digits is a multiple of 3. So if both these criteria are met, then the number will be divisible by 6. Let's look at the divisibility by 8. We'll look at the divisibility by 7 in a little while. So in the similar way as we talked about 4, a number is divisible by 8 if the number formed by its last 3 digits, which is hundreds digit, tens digit and ones digit. If these 3 digits are divisible by 8, then the number will be divisible by 8. Divisibility rule for 9 is similar to the one for 3. If sum of all its digits is divisible by 9, then the number is divisible by 9. So for 3 we know that the sum of all the digits is divisible by 3. Then the number is divisible by 3, and same is for 9. The sum of its digits has to be a multiple of 9. Divisibility rule for 10 is very simple. The number has to end with 0. So every number ending with 0 will always be divisible by 10. Divisibility by 11. A number is divisible by 11 if the difference of sum of its digits at odd places and the sum of its digits at even places is either 0 or divisible by 11. Then the number will be divisible by 11. So say for example we have a number 1, 3, 3, 1. Now what are the even places? This and this. So this is the first place, this is the second place, this is the third place, this is the fourth place. So even is this 1 plus 3. If we add these, it becomes 4, and then we add the odd place digits, it again becomes 4, and we subtract this. If we get 0, or instead of 0 if we get it as a multiple of 11, then in both the cases the number will be divisible by 11. Now divisibility by 12, as we said in divisibility by 6, we said 6 being a product of 2 and 3. If a number is divisible by both 2 and 3, it will be divisible by 6. Same is true here, because 12 is 3 multiplied by 4. So if we check the divisibility of the number by 3 and 4, then the number will be divisible by 12. Let's now check the divisibility of 7, 11 and 13. So 7 is the one which we left. So there's a common rule. For 11 we've already talked about one rule. Now we'll see another rule which also using which also we can check the divisibility by 11. So this rule now applies to all three of them, 7, 11 and 13. So a number will be divisible by 7, 11 and 13 if the difference of the number formed by the last 3 digits of the number and the number formed by the rest of the digits is divisible by 7, 11 and 13. Then the number will be divisible by these 3 numbers respectively, not all 3. We are saying whichever is applicable. So let's take an example of 137125. We take this number. So now if we want to find out, check its divisibility by all of them, by 7, 11 and 13. So what we can do is the last 3 digits is 125 and the remaining is 137. So if we subtract the last 3 digits from the remaining digits, so which is 137 minus 125, we get 12. Now this number is neither divisible by, this 12 is neither divisible by 7 nor by 11 nor by 13. So this number 137125 will not be divisible by any of these numbers 7, 11 or 13. Now if instead of 12, if we get a 14 over here as the difference, then this number would be divisible by 7, but again not divisible by 11 and 13 because 14 is not a multiple of the other two. And similarly, if instead of 14 we get 11 as this subtraction result, then the number would be divisible by 11. And instead of 11, if we get something like 13 or 26, then the number would be divisible by 13 and not by 7 and 11. Now we'll see the divisibility by 14. Again, we use the same rule which we used for 6 and 12. So a number which is divisible by 2 and by 7. So all the even numbers divisible by 7 will be divisible by 14. And the last one that we check here is the divisibility by 15, which is a number divisible by 3 and 5. So that number will be divisible by 15. So any number ending with 0 or 5 and the number being divisible by 3 will always be divisible by 15. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.